بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Okay, so today we are going to do the solution for major exam of spring 2017. And this one, in this major exam, we are going to extend the class image that we did before in the quiz 1. And here we are going to follow a contract first approach. So what is contract first approach? First of all, we need to define the interfaces, and then we define the implementation of these interfaces. So I explained to you that whenever our code becomes more and more complex and larger in size, we need to make a better structure for this code. Okay, and one of the best practices in software development and software engineering is to first define interfaces which will contain the abstract methods only. Okay, and then you implement these interfaces into the classes and you provide the implementation of these abstract methods. So this is the idea. So later on, anyone who would like to extend the code, he doesn't need to go through all the details of the implementation or would like to use the code into a test class or something. He just need to create object from the interface. Okay, declare the object as an interface and then create them from their classes. Using polymorphism, and then he will have the list of all the available methods defined in the interface. This is basically the main idea. So here we start with building the interfaces for the image application and specify all the operations that images can do. Okay, so we're going to specify all the operations. It means the abstract methods that we are going to define. We will consider some changes with respect to the previous quiz, that is quiz number 1 and quiz number 2. So in quiz number 1 we have made just classes, in quiz number 2 with inheritance, and now we're going to use, even better, use interfaces to define the abstract methods first and then their implementations. نعم؟ No. So we first define a color, which can be gray color or RGB color. So this means that here we have a relationship between gray color and RGB color with color. Then we define pixel, which contains a color, which can be either gray color or RGB color. Okay. Then we define an image as two-dimensional array of pixel objects. Then every image can be either gray image or RGB image, depending on the color of the pixel. And first, let's define the interfaces for this application. So the first interface is color. I sent you yesterday here 2 packages on GIT Hub, so you should have downloaded them, which contain here the declaration of classes, and they are not still implemented. So your job here is to write these interfaces first, and then to complete the missing code into these classes. So usually I give you something similar to this. So you don't need to write the class from scratch. Everything that is obvious, it's written. You just need to complete the missing code. So let's start by the class color, or the interface color. So here we have public this is color. Public interface color. Define an interface for color. This is defined. It has no method. It has a comparable interface. So here we said that in order to have a comparable interface, we're going to extend, okay, comparable color. So why we define an empty interface is usually to have a generic type. Okay, so later on when I'm going to create a color, I can use polymorphism, okay, color, and this color can be instantiated either as gray color or RGB color. So this is just to use polymorphism on color objects. So an interface can have 0 or 1 or more abstract methods. So in this case, we don't have any abstract method. It's just an empty interface like this. And then we define gray color. So gray color here, public interface gray color. Yes. What we should do here. So gray color is one of the types of colors. How we translate this? Yeah, extends color. And we don't do implement here because gray color is an interface and color is an interface. So we use color. Okay, so we use extends. If you use implements, no. It's going to be an error. So a class implements an interface and an interface extends an interface. This is the rule. Okay? Okay. And then defines an interface for gray color. It has a method to set color as a byte. Okay, public, abstract, void, set gray or set color. Byte color. Okay, and it has another method, public, abstract. It has a method to get a color and return a byte. Return a byte, get color. That's it. So now I know every class that will implement gray color will have to provide an implementation to set color and get color. And not only that, it will be also comparable, because comparable color is also inherited from color. Okay? So you can see now there are relationships even between the classes. Okay. We will do the same for this is gray color, right? And then the next one is RGB color. Okay. So we go to RGB color now. Public interface RGB color extends color in the same way. Define interface for color. Okay, what it must do? It has set and get method for setting red, green, and blue colors. Very simple. Public, abstract, void, set color. So here it has three colors as byte, red, byte, green, and byte, blue.
It's okay to do one step by step.
What does it mean step by step?
Like set for green, set for red, set for blue.
No, here all in one for setting red, because this is like we did in the quiz. Gray, could be. Yes, you can do public, abstract, void, set, blue. And green. Okay, both are acceptable. Okay. And by the way, even if you remove abstract, it will work. Okay, because so you can even put it, but it's better to put every color. So we need to make also get methods for all of these. So we get no parameter here. Then every color is of type byte. So now we are done. Okay. Now the next one.
So Doctor, first one, we did the first one or the second one?
Sorry.
The set color.
Yes.
We should do one of them, right?
Okay, both are acceptable. Yes, one of them.
One of them.
Yes. Okay. And then we go for pixel. Okay, so I'm going to take this, go to pixel here. So define an interface for pixel, public interface pixel. It has get and set method for reading, modifying a color. It is a comparable interface for reading, modifying a color. Okay. So we have public abstract read a color. It's going to return a color. Get color. Okay, because a pixel contains a color. Okay, so here get color and public abstract void set color. So here we use the color interface. A color in pixel is of type interface color. Okay, so here not byte. First of all, we defined an object color, and then we use this object into pixel using composition. Okay, and inside color we have byte. Inside color we have byte, which can, if it is gray color, it's 1 byte. If it is RGB color, we have 3 bytes: blue, green, and red. And here the interface, it is a comparable interface. X stands comparable pixel. Okay, so you read line by line, you respond line by line. It's very simple. This is how you should do in the exam. Then we define interface for image and objects. So this is image for image objects. Go for image. Okay, define an interface for image, public. Interface image. So you're going to translate the English into some code. That's it. Quite simple. It has get and set method for reading, modifying width, height, and name. Okay, public abstract string get name, public abstract height. So height is an int. Get height, the height of the image. Public abstract int get width, and I have to do the same for the set. Public abstract void set name string name here, okay, and public abstract void set height int height, and public abstract void set width int width. The width are of type int and the name is of type string. It has method get img, okay, public, that returns two-dimensional array of pixels, okay, it's called get img. It has a method called randomize, public abstract then we have public abstract randomize, which generate random colors for the image, void. It is a comparable interface, extends comparable image. That's it. Okay. Just you need to follow the guidelines and write. Then we have gray image. This is gray image. Yes. Gray image define an interface, public interface. Gray image. And it has no method. And of course here, extend image. You have to do it. Okay. And same thing will be for RGB image. And we are done with the interfaces.
Like color that and the pixel or the get pixel in the image. It's an interface. When you implement in the class, it will be also interface.
Yes.
How to convert it? Or like to set the value. That objects.
The interface is like abstract class. You define, you use polymorphism, you declare as an interface, and you create as an object. Now we're going to do the implementation. We will see. Let's do the implementation first. Now.
Does it matter if I leave the interfaces and other classes in one package, or should I?
Well, for organization, it's better to put them into different places.
Yes, it's better, but if I do it like this, it doesn't matter. It doesn't have
Everything works, yes. Everything works, but there is a difference between an organized code and a messy code. Yeah, there's a difference. Is that we organize, because now we are doing small programs, even these are small programs. When we have very large program, we have to create packages and organize them according to certain criteria to be able to track your classes and interfaces. Otherwise, you can get lost. If you have 200 classes into one package, it's difficult to search for one. Or thousands of classes, you see. So that's why the organization into packages is something very important as well. Okay, now the next part. So we have completed all of this. Now you will complete the missing code in the classes provided you in the packages. In the package, this one. Okay, read the class, gray color IMPL. So when I say read the class. Because sometimes there are information that you might need when you develop your code. Okay, there are some methods that you might need. Some students do not read the classes, and sometimes they develop some method that I already provided to them. So they lose time without anything. Okay, so here you have to go to gray color IMPL. So the convention here is that the implementation of the classes, we use IMPL for specifying that this is an implementation of an interface. There is another convention you will find in other major exams that I start the interface with capital I. For example, I can say I color, I gray color, I RGB color, and in this case I will define the classes implementation just by color, RGB color, gray color. There are two conventions on how to write interface and their class implementations. So here I have used one of them, that is I write the interface like the normal name, and I add IMPL at the end of the class implementation. In some other exams you might find the other convention that is starting with I for the interface and the normal name for the class implementation. This is how we can differentiate both of them. So here we have gray color. It has byte color here, a constructor, a copy constructor, and toString method. So gray color here we have to import because it was not imported. And then we see what is requested. First, complete the missing code in the declaration of the class to implement the right interface. Okay, let me take the code here. So what is the missing code here? Okay. So here we need to do what? Implements gray color. So now if I implement the interface, I put a contract. I have to implement all the abstract methods that were defined into gray color interface. So if I look at gray color interface, I have to make sure that these two methods are implemented here. Okay. So we already have get color and set color. Okay, probably I can add here override, just to mention that this is overridden from the. So what is missing here? Why is still showing a problem? Although I implemented these two here.
Is it because gray color extends color? So there's more?
But gray color doesn't have any method. Why it has a problem? We can look here. Gray color is not abstract and does not override abstract method compare to. What's the issue with compare to? Why we have to implement compare to here? Because gray color extends color, and color is comparable. So gray color IMPL is also comparable, and here we have to implement, we have to override. Okay, public int compare to what? What to put here? So same thing, because we're going to take it from comparable color. So here it's like you have written implements comparable color. It's like you do the same. We have no comparable color. It's inherited from gray color. Okay. So now override. I need to import color. So I import color, and then I have to check how to do that. gray color A is greater than gray color B if the value of the color attribute of A is greater than the value of B. Okay, so here we can return this dot get color okay, which is a byte minus color dot color does not have anything.
We need to instead of
Here we need to do what? This is one difficulty now.
instead of make sure this object is
Yeah, if I make color dot, color does not have any, because color is just a generic interface with no methods. But now I'm going to compare a gray color with a gray color. So I need to do what? This color should be gray. So I need to compare only if it is an instance of gray. If what? Color. Instance of gray color. صح ولا؟ In this case, I can make casting gray color GC equal gray color and here minus GC dot. Now I can get color. And get color is defined where? It's defined for the gray color. Voila. Okay. Now only return so if the color is not gray color, we return this particular value in the other case.
the color interface defined I color. It is the same. I just converted to like downcasting. Yeah.
Yeah, you need to make downcasting.
It doesn't make a difference.
Mm.
It's the same.
Is this clear? Okay, so here we have to make compare to color. We don't have an option. Okay. If you make here compare to gray color, no, it will not. You will have compilation error here. And comparable is defined with color. So compare to will take an attribute color. Okay, we don't have the option. Okay, so now this color can be of two types, gray color or RGB color. In this class, we are going to compare gray color with a gray color. If it is not a gray color, so they are different. We return minus 9099. Okay, and now if it is a gray color, we do the conversion and then we compare. واضح؟ سويت كده يا وليد؟ الآن واضحة. Okay. Okay, you see, two questions, very simple. Implement this and this. You don't have to write too much code. But of course, this shows an understanding of polymorphism. Okay, if you do the other practicing, especially the two videos that are available on the website, you will get more example like this, so you get more treat to that. Okay. Now we will do the same. It's basically the same thing we will do here. Okay, so not to lose time. Here, the only difference is that A is greater than B if the sum of the three colors of A is greater than the sum of the three colors of B. Okay, so I will do the same here for gray, for RGB color. Okay, first of all, I need to implement RGB color. I need to import. Okay, and of course here I have to override implement all abstract methods. Okay, so I will remove this from here. I can implement that. Okay, no problem. It will not take me too much time. So set color here, set blue, blue, set red, red, and set green, green, green. Okay, forget color, this I don't need. Okay, so I'm going even to remove it from here. And we get one by one. Otherwise, I have to return an array and so on. Where is the RGB? And then what remains? Remains the last color here. We do the same thing, okay? Nothing special. So I'm going to take this compare to here. Cancel. If it is instead of RGB color, okay. And then we have to change int sum this, okay, this dot red plus this dot green plus this dot green, and int sum color RGB dot get blue plus RGB dot get green plus RGB dot get red. So here I can do
Can I write RGB dot red or dot blue?
it's possible, yes. Okay, I return the sum of the difference of the two sums. It's positive, negative, or equal. Okay, you remember that compare to should take one of three possible values. 0 if they are equal. So if they are equal, the sum will be equal and the difference will be 0. Okay, positive if this is greater than the parameter, and negative otherwise. Okay, that's why here when you have int, you can make difference. If you have double, you don't make difference. You have to make with if statement. If this one is greater than 1, return 1, or return -1, or return 0. But if you have int values, because here we're going to return int, okay, so it's not a problem to make this difference like this. But if you have double, you should not make casting, because casting you will lose some precision. So in this case, you compare one by one. And then we go for gray pixel implementation. Gray pixel implementation. So pixel has two types. We have gray pixel implementation here. Okay. Read the class gray pixel implementation. So this is the class here. Gray color must be imported. So I'm going to add import. I have to import also color. So now everything is fine. And then see its attribute color defined as gray color. So here a gray pixel is defined by a gray color. That's all. And then we have a constructor, get color, set color, and so on. First, complete the missing code in the declaration and implement the right interface. So what we have to implement here? Implement what? What to implement? Pixel. Okay, we have only pixel interface. We don't have. So I have to import it. And of course here we have to override all abstract methods. So what are the abstract methods that you have to override? Compare to. Why we have to override compare to? Because pixel is comparable. Okay, if you see here, we define pixel is comparable with the pixel. Okay, so here we need to implement compare to method. Okay, we have to see what is the comparison criteria. Pixel A is greater than pixel B if the color attribute of A is greater than the color attribute of B. Okay, so this is pixel. So we have this dot get color and we have pixel dot get color. How to compare between both?
Make sure that color of let's say RGB.
No, ما عندناش RGB الآن. We have الجري color.
Sorry, green. We have to make sure this.
No, you don't have.
Or we call the method.
الآن pixel فيها color وthese فيها color. Okay? Both they have color. And colors, we already define them as comparable. So how to compare between the color of this and the color of... Look now, if you don't make dot, what do you see? Because the color is comparable. صح ولا؟
So this would compared to the other.
We're going to compare to the other color. So we just return the result of the comparison.
But I can do the other way, but it's not sufficient. Yeah, to it.
Okay, so what is the comparison criteria here? Let's bring it and try to understand it. So this is why I told you you have to do this at home. Because at home you can think about and check. Now I'm just presenting things and explaining them. So pixel A is greater than pixel B if the color. So if I don't do the following, what I should do? So we can do it another way. Okay, so since we have here gray pixel, okay, I can create a gray color. This gray color equal this dot get color and I make casting. صح ولا؟ So now if I want to do it in the long way, I can do a casting here. I can do another casting for pixel color. Okay, and then this gray color, it has a value inside, like we did before. Return this GB dot get color اللي هي byte minus get color اللي هي inside. So لأنه الآن what do we have? You have to understand the classes how they are built. لأنه الآن we have composition. So we have a first box اللي هو البايت color. Okay, and then the byte color. And then we have another box اللي هو الجري color. Okay, inside the gray color, what do you have? We have this one. Let's send it back. Okay. And here we have the bigger box اللي هو ايش اسمه؟ هذا gray pixel. Okay. So gray pixel has a gray color, and gray color has a byte that is color. Okay. الآن we would like to compare a gray pixel with a gray pixel. الطريقة الثانية اللي بينتها أنه we convert the pixel into gray pixel and we access the byte and we compare the byte. لكن this is not good. we already did this for the gray color. And we have defined gray color is also comparable. Do not forget. صح ولا لا؟ So it has a compare to method. So I am able to compare a gray color with a gray color without redoing all of this. So instead of doing all of this, I can have this dot color, okay, return if you want. This dot gray color, I want to call it GC, not GB. Okay, this one is comparable. It has dot compare to. Okay, I will compare it with pixel. Okay, and this is actually the same as the following. Okay, so either we write this one or this one. So I don't even to write this code. I can write it this dot get color, which is this one, compare to pixel dot get color, because they are comparable. Okay, and this is possible because, as I explained here, we have composition and gray color is comparable, so we can use the compare to method in order to make that comparison. Okay, you will find more similar examples into the other major exams. Okay, so do them before the major on Sunday. So let's stop here because now it is time. Tomorrow we are going to continue the other parts. So try it at home. Okay, so I remind that yesterday we did all the interfaces and then we started to make these different classes. So these are the interfaces that we did. The interface color, gray color, RGB color, gray image, pixel, and so on. So we did all the interfaces. And then we started to do the different classes. So here what was requested is to implement the interfaces in the classes and complete the missing code. So yesterday we did the following one, this one, gray color. We did also gray pixel and RGB color. So all what was needed here is to complete the compare to methods, right? Because when we implement RGB color, okay, the compiler will request that you override the abstract method. So several abstract methods were already implemented, method set blue, get blue, and so on. But compare to must be overridden here, as you can see. So we reach at this stage. So we have compared. Look now, the last thing that we did is that we compared two pixels based on their color. I put a note that color objects are already comparable. So this is to use compare to method when you want to compare the color of two, when you want to compare the colors of the pixels. Instead of making the comparison again, okay, we already made the color comparable in order to use the compare to method later on. Is that clear? Okay. So whenever you have, for example, a string is comparable. Now, for example, if you want to compare two IDs or two string values, you can use compare to, okay, because string is already comparable, number is already comparable, double is already comparable, okay? So all of these types are comparable. We can use compare to methods. If there is no compare to method, in this case, you do like we did here, comparison one by one. You see what is the comparison criteria, and then you compare between both, okay? Now let's go for RGB pixel IMPL. Okay, so now we take this one, we go to the class RGB pixel IMPL, and let's see what is requested. Okay, see the attributes and the other methods. First, complete the missing code in the declaration class to implement the right interface. Okay, so here we need to implement the right interface. What is the right interface here? Implements RGB pixel. And then you have to import. We don't have RGB pixel, we have pixel. So here we're going to import pixel. Okay, we need to import RGB color as well, the interface. And you have to import color also here. Yes?
Can we define RGB color as an interface, not class?
RGB color is an interface, yes.
And the test methods, I define also.
The class IMPL, they have use IMPL.
In the test class, I defined as interfaces.
Yes. Okay, so here implement pixel. This is the interface that you have to implement. Then override the method public set color, which set the RGB attribute to the color parameter of the method. What is set? Okay, so we have to override set color public. Even if I don't say override, okay, you have to implement all the methods, all the abstract method of the interface. So here void and color. How to do that? Yes. عليها خطية. And we have to override everything. So here, not abstract does not override compare to method pixel. We have to also override compare to method. Okay, we have, because pixel is comparable. واضح? Public int compare to color. Pixel. Okay. Look now, there is nothing. What you can do, you can come here and check what is the, is going to write down for you. Okay, so we have two methods here. we have to set the color. So first of all, so in principle what we should do, we should assign, so RGB is equal to color. But here we can't. Why we cannot?
RGB is not a color. Different.
RGB is a color. It's an RGB color.
Compatible with heights.
Converted.
Yes, here we have to convert because RGB is a subclass of color. We cannot make this assignment. The opposite is possible. واضح? So in principle we should do what? RGB color. Okay, but before that what we should do? We should make sure that it is of the same type. If color instance of RGB color, then we do the assignment. واضح? Else throw new illegal argument exception color is not RGB. واضح ولا؟ Okay, so now we have overread and set color, and then we have to make compare to method. It says complete the compare to method pixel with the following comparison criteria. Pixel A is greater than pixel B if the color attribute of A is greater than the color attribute of B, and color is comparable. So what we should do? Yes, return what? Return this. We're going to compare the color. Get color. Dot. Pixel dot get color. See, quite simple. That's why I told you, if you understand and you do practice, these kind of things in the exam will be simple. But you need to understand how to make it. Now it seems simple because we're doing it. But when you read the question, you must make sure that you are able to know when to use this, when to use that, how to find the solution. And this is what needs practice. Voila. Okay, so now we are done. Okay. We are done with this one. And what I suggest to you, whenever you complete something, okay, maybe because I don't give the Word document from the beginning, try to copy paste, but okay, so into the Word document. But I will send you like 15 minutes in advance. So the next question now, image IMPL. I will take this, go to the class, read the class image IMPL and see the attributes, width, height, name. Okay, so we are here. The class implements all methods of the image interface except the method randomize. You see, you don't have to implement too many things. Okay, sometimes I provide implementation of some methods of the interfaces. So you need to see what is the missing code. If there is a missing code, you complete it. If there is no, so you don't do it. Later on, when you copy paste, so there is something important. Do not copy all the class. Now, for example, if you are going to copy here the code, this is very important. Please follow that. So this one, for example, don't come and, okay, you bring me the whole class. No. Don't copy the code that already exists. This is not acceptable. So what you should do, only what you have made changes. This is what I'm going to look at. Okay, don't lose grade because of copying everything. So we have changed the declaration of the class. Okay, so what is the declaration here? So I'm going to copy that one, and then what we did two methods. So I copy them. Okay, Control C. They come here. Copy them here. So this is the solution. Do not copy everything. واضح? So now, for example, for this code, gray pixel IMPL. Okay, what we did? Gray pixel IMPL. We did this one. So we did this declaration. Okay. And then we did the compare to method. This is what you copy. Do not copy everything. واضح? Okay. Yes.
When we use compare method in pixel, we call the color compare to, but there are two override methods. We'll take it.
Okay. So let's get back to image IMPL. First, complete the missing code. So here we have implements image. And here we have to import image. So it's possible that sometimes you have extends a class and implements an interface. Okay, depends on the relationships. Now in this case we don't have, but you will see in the other exams there is the exam about the graph. This is very important. It's important to do it because it contains some also useful information for the major exam coming. Okay, and in that major exam we use extend and implement for the same class, because when there is inheritance we have also to show the relationship of inheritance and also show the relationship of implementing an interface. So in this case we don't have, because everything was defined as an interface. So this is now how we complete the missing code of the declaration, and then complete the method compare to. So randomize here. Okay, so the method randomize cannot be defined in image IMPL. Why? Because it depends on the type of the image. If we have gray image, we're going to randomize only gray color value. If we have RGB color, we're going to randomize three values: blue, green, and red. So that is why randomize is going to be implemented where? Into the subclasses of image. واضح? So here we don't have to implement randomize. So here we have to complete the compare to method image. Image A is greater than image B if the number of pixels of A is greater than the number of pixels of B. So how to calculate the number of pixels in an image? Image is two-dimensional array. How to know the number of cells in two-dimensional array? Width multiplied by length. Number of rows multiplied by number of columns. إذا كان عندك 3 by 3 you have 9. If you have 3 by 4 you have 12 elements. صح ولا؟ Okay. So here the comparison criteria will be width and height multiplied by height of the image minus IMG get width multiplied by IMG get height. So this gives the number of pixels of this image, and this gives the number of pixels of the image, the parameter image. We make the difference to have either a positive value, negative value, or 0 if they are equal. Same principle. واضح? Okay. So you have two lines of codes to write. You have to write this one, implements image, and then to override the compare to method. You see, all the code is very small and simple. Now we go to gray image IMPL. Okay, gray image IMPL here. First, complete the missing code in the declaration of the class. Same thing. We have to implement. Implements what? Gray image. But it's not only this. We also extend image. Okay? Because now you have to capture all the relationships. Gray image is a subclass of image. No. Image IMPL. Okay? And also implements gray image interface. واضح ولا؟ And this is an example from what I talked to you about. Because here we have inheritance and we implement an interface. Okay, complete the missing code in the declaration to implement the right interface, also to extend. If you see in the previous quiz, we have also made extend between gray image and. Okay, so I have to import pixel as well. And then what is missing is to override existing methods. So also override the method randomize such that the image array, okay, so I can do here, implement all abstract method, and I have to implement the method override, randomize. So what does it do, randomize? Image array, so this image array will have pixel object with random gray colors. How to do? We have to make a for loop. Yeah, for int I equals 0, I smaller img dot length, I plus plus. So it is two-dimensional array. I have another for loop for int g equal to 0, g smaller than img dot length, g plus plus, and here img I g, so this is the value that I'm going to put into the pixel. So what to put here? Math dot random. So we're going to use math dot random, but here what is the type of img? It's pixel. So I need to create a new pixel. صح ولا؟ I cannot assign just a value. Okay? So here it's new what? Pixel is an interface. What are the concrete class from pixel? No? We have already made RGB pixel and gray pixel. Which one? So here we have gray pixel because you are going to create gray color. So here we use gray pixel IMPL, the concrete class. Okay, and you have to see the constructor now. I go to gray pixel IMPL and the constructor just take what? A color. Which type of color? Gray. So here I need to create a new color. صح ولا؟ What type of color I need to create? gray color. Because of polymorphism, gray color is a subclass of color, so the constructor will accept. واضح؟ شفت الآن polymorphism. We have polymorphism, and here inside gray color, we look at the constructor, we take one byte. So this is the random value. واضح؟ So this is the random value. Let's make here byte color value equal math. So math.random is going to generate something between 0 and 1. So I will multiply by 255. Okay. And then I will cast to byte. Then we'll take this value over here.
Okay, but sir,
Hmm?
the second for loop, shouldn't we write image bracket j dot length?
Hmm?
The second for loop, image I dot length.
Yes, you are right. Image I dot length. Okay, so here we generate a random value. Okay, then we assign to imgig a new gray pixel. Inside the new, because of composition, we have color, and inside color we have, you remember yesterday I made you a figure, one box inside the other. This is composition. Okay. Okay, gray image, gray color, and then the random color value. Is this clear? واضح ولا؟ Okay. Of course, because now if you are going to just make the random value here, it's not going to work. Because this one, the type of this one is pixel. Okay, so we will ask what kind of pixel? It's a gray pixel. So our class is called gray pixel IMPL. I'm going to create that. I will look at the constructor. It takes a color as parameter. So I create a new color, gray color. And the gray color take the random value as parameter. And this gives the following expression. It looks long, but this is the way on how we should do it. Okay. So that's it for this class. And the same will be also for this class. Now you should be able to do the same for this one. Anyone tried this, faced some difficulties, or did anyone try this at home? Try to solve it? No one? Okay. Of course, the same thing here. What we should do? We should complete the declaration. We extend what? We extend image IMPL and implements what? RGB image interface. So this is the declaration. Same thing. Okay. Do you understand these relations or no? You understand these relations? Okay, so just these relations, we put them into effect. Okay, that's the whole thing. Of course, I need to import these different things. And here what is missing is to override the abstract methods, randomize.
So we'll copy the other one and edit.
Yes, we're going to copy the other one. Now you understand the process. What is going to change? So let's say this is blue value. We're going to generate 3 random values now instead of 1.
Red, blue.
Red and green. هذوما 3 random. صح ولا لا? Now IMG is what? Is a pixel.
RGB.
And it's RGB here. شفت الآن because of polymorphism, instead of making gray, I'm going to change to RGB. You see now polymorphism, why it is important? You see why we have created now the class pixel? We are able now to create different type of pixels, okay, depending on the type of the image. واضحة الفكرة؟ Okay. Now, of course, because if I look at this one, RGB pixel IMPL, the constructor will take an RGB color, not a gray color. So here, I have to change this one to RGB. Okay. And here, RGB color the constructor takes 3 values: red, green, and blue. Okay. So I put the first parameter as red, then green. So what I should put here? Red value, green value, and blue value like the constructor wants it to be. And you can see now I don't have any error. This is randomized. Yes?
The random method from 0 to 255.
Because a byte is a value between 0 and 255.
Should we multiply by 265?
Here, maybe, depends on random whether it can take 1 or no. If it takes 1, we have to put until 255. But it should be fine like this. واضح? Okay. So we are done. That is the whole exam.
The major will be test class.
Maybe yes, maybe not. وفي ده ناتي لما الميجر يكون على هذا كان long, so I didn't make a test class. I put it according to the time given to the students. Yes.
Regarding the weather app, I tried doing it and I think I did it